It's official. NASA confirms we've found 5,000 worlds outside the solar system. In January 1992, two cosmic objects forever changed our galaxy. For the first time, we had concrete evidence of extrasolar planets, or what we call exoplanets, orbiting an alien star. Two rocky worlds, and they were whirling around a star 2,300 light years away from us. Now, just over 30 years later, that number has exploded. This week, March 21st, marked the hugely significant milestone of over 5,000 exoplanets confirmed. To be precise, 5,005 exoplanets are now documented in the NASA Exoplanet Archive, every one with its own unique characteristics. Each and every one of these exoplanets appeared in peer-reviewed research and been observed using multiple detection techniques or methods of analysis. The pickings are rich for follow-up study to learn more about these worlds with new instruments such as the recently launched James Webb Telescope and upcoming Nancy Grace Roman Space Telescope. And astronomer Jesse Christensen of NASA Exoplanet Science Institute at Caltech says it's not just a number. Each one of them is a new world, a brand new planet. I get excited about every one because we don't know anything about them. The first two worlds ever confirmed, discovered by astronomer Alexander Wolfsan and Dale Frail, were exoplanets 4.3 and 3.9 times the mass of our Earth. They were whirling around a dead star known as a millisecond pulsar, which sends out beats or pulses of radio waves on millisecond timescales. The third planet, much smaller at 0.02 times the mass of our Earth, was discovered orbiting the star, since named Lick, L-I-C-K-S-E-H, in 1994. The exoplanets were named Poltergeist, Phobiter, and Droger, respectively. The discovery suggested that the galaxy had to be teeming with things. Pulsars are a type of a neutron star, the dead cores of massive stars that have ejected most of their mass, then collapsed under their own gravity. Their formation process is pretty extreme, often involving colossal explosions. If you can find planets around a neutron star, planets have to be basically everywhere, Wolfsan says. The planet production process has to be very robust, he explains. But there was a catch. The technique used to identify these exoplanets was based on the very regular timing of pulses from the star, which are altered very slightly by the gravitational influence of the orbiting bodies. And alas, this technique is restricted to pulsars. It's unsuitable for main sequence stars that don't have regular millisecond pulsations. But when astronomer William Boricki of NASA pioneered the transit method, which observes faint regular dips in starlight as an exoplanet passes between us and the host star, exoplanet science then exploded. The Kepler Space Telescope, launched in 2009, contributed over 3,000 confirmed exoplanets to the list, with another 3,000 candidates waiting in the wings. In addition to the transit method, astronomers can study the gravitational effect exoplanets exert on their host stars. As the objects in orbit a mutual center of gravity, a star appears to wobble slightly on the spot, altering the wavelengths of its light. In addition, if you know the mass of the star, you can study how much it wobbles to infer the mass of the exoplanet. And if you know how intrinsically bright a star is, you can infer the size of the exoplanet. This is how we know that there are exoplanets out there in the universe, very, very different from those we have in our home system, our solar system. Hot Jupiters are enormous gas giants on incredibly close orbits around their stars, the proximity resulting in exoplanet temperatures that can be very hot, even hotter than some stars. Mini Neptunes inhabit the size and mass regime between Earth and Neptune and could potentially be habitable. There are also super Earths, which are rocky like Earth but up to a few times the mass of our Earth. Because studying exoplanets directly is very hard, they are small, very dim, very far away, and often very close to a bright star whose light drowns out anything the exoplanet might reflect. There's still a lot we don't know. There are also still a lot of worlds out there beyond our current detection thresholds. But in the years ahead, those thresholds will retreat against the advance of technology and new analysis techniques, and we may find a variety of worlds beyond our wackiest dreams. Maybe we'll even find traces of life outside the solar system. Baruchi says, I get a real feeling of satisfaction, really of awe of what's out there. None of us expected this enormous variety of planetary systems and stars, and it's just amazing. This is by Michael Starr on Science Alert, and let's watch the video concerning the 5,000 exoplanets as NASA describes them. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.